Elon Musk recently unveiled a revolutionary anti-gravity fighter jet, right as nations race to boost defense tech and gain air superiority. This next-gen aircraft, offering a massive strategic edge, has stunned the world. But how will it shape aviation? What can it really do? Stay tuned as we explore Musk's game-changing invention. Meanwhile, SpaceX's Starship made huge progress during its third test flight. Launching from Texas, the two-stage rocket hit many milestones. It aimed to send the upper stage around the globe, re-entering over the Indian Ocean. Though contact was lost near the end, Musk celebrated the flight as a big success. In past launches, April and November, the 120-meter rocket exploded shortly after takeoff. This time, all 33 engines fired perfectly, and the rocket separated as planned. 2 minutes and 44 seconds in, the upper stage continued past the Atlantic and over southern Africa, capturing stunning views of Earth from 100-plus miles above. Next came re-entry. Video showed intense heat and glowing gases just before contact was lost. Shortly after, controllers confirmed the ship didn't survive, likely breaking apart during descent. Things didn't go fully to plan. The booster was supposed to slow down for a soft-sea landing, but came in too fast and was lost. The upper stage also failed to reignite its engines for re-entry. SpaceX will analyze flight data to learn what went wrong. Still, the mission is seen as a major step forward. Musk promised up to 6 more test flights this year. Starship is a whole new class of rocket. Its 33-engine booster produces 74 meganewtons of thrust, more powerful than anything used during the moon missions. If perfected, Starship could revolutionize space travel. It's fully reusable and can carry 100-plus tons into orbit, dramatically lowering launch costs. That's key for Musk's Starlink project, which already has over 5,000 satellites in orbit. During this test, SpaceX even tested the satellite deployment door mechanism. Long-term, Starship is central to Musk's dream of sending humans to Mars. NASA also has big plans, using a modified Starship to land astronauts on the moon for its Artemis program. NASA hopes SpaceX proves the vehicle's safety by 2026. After this flight, the FAA announced an investigation into how both stages ended, standard protocol for all commercial space flights. SpaceX will lead the review to identify both successes and failures. Looking back, SpaceX's journey began with the Falcon 1, the first privately funded liquid-fueled rocket to reach orbit. It was designed to be affordable, simple, and reliable. It could carry around 450 kilograms to low Earth orbit and help test tech for the larger Falcon 9. Falcon 1's first stage, made of aluminum alloy, used a single Merlin engine with parachute recovery. Later versions used a Merlin 1C engine with 92,000 pounds of thrust. Its second stage used a Kestrel engine with 7,000 pounds of thrust, built for efficiency in the vacuum of space. Falcon 1 to Falcon 9, how SpaceX transformed rocket launches. In 2005, SpaceX priced the Falcon 1 rocket at $5.9 million, increasing to $6.7 million by 2006. By 2009, Falcon 1 cost $7 million, while an upgraded version reached $8.5 million, with discounts for multiple flights. Initially built to carry 600 kilograms to low Earth orbit, that capacity was reduced to 420 kilograms as prices rose to $9 million. A final model aimed for 1,000 kilograms at just $1 million. Though retired in 2009 after 5 flights, Falcon 1 laid the foundation for Falcon 9, now central to SpaceX's operations. Falcon 9, a medium-lift, 2-stage rocket, launched for the first time on June 4, 2010. Its first mission to resupply the International Space Station, ISS, was on October 8, 2012. In 2020, Falcon 9 made history as the first commercial rocket to carry humans to orbit. By 2021, it held the record for most U.S. launches ever. The rocket has a strong track record. 364 successful launches, 2 in-flight failures, 1 partial and 1 pre-launch failure. Falcon 9's first stage, or booster, carries the second stage in payload partway, then separates. The second stage finishes the trip to orbit. What makes Falcon 9 unique is its reusable booster, which lands vertically. a breakthrough first achieved in December 2015. As of August 28, 2024, SpaceX has landed Falcon 9 boosters 326 times, with some flying up to 23 missions. Both stages run on Merlin engines, fueled by supercooled liquid oxygen and rocket-grade kerosene. The Merlin 1D engines, used since the Block 5 version in 2018, generate 192,000 pounds of thrust each. The booster has 9 engines in an octaweb pattern. The second stage uses one engine with a nozzle that varies by mission. Falcon 9 can still succeed even if up to 2 engines fail, by burning the rest longer. Each engine has its own controller, managed by triple redundant computers, constantly cross-checking for safety. These use PowerPC processors and thrust vectoring for flight control. The rocket's fuel tanks are made from aluminum lithium alloy, welded using friction stir welding for strength. The second stage tank is a shorter version of the first, built with the same tools and materials. The interstage, connecting both stages, is a carbon fiber aluminum composite with pneumatic separation and reusable latches, streamlined from 12 to 3 connection points in later versions. The payload fairing, which protects cargo during ascent, is 13 meters long, 5.2 meters wide, and weighs 1,900 kilograms. It's made of carbon fiber over an aluminum honeycomb, built in Hawthorne and tested at NASA's Plum Brook Station. Since 2019, these fairings are reusable too. 4 onboard systems. SpaceX uses fault-tolerant Linux-based software coded in C++ and built with off-the-shelf, radiation-resistant components. Each stage and engine has independent flight computers, ensuring redundancy and control. SpaceX's X-1. The future of air warfare? SpaceX boosters not meant for recovery lack landing legs or fins. In contrast, reusable boosters feature for extendable legs and grid fins that deploy after stage separation. Early Falcon 9 versions used aluminum grid fins, later upgraded to larger, heat-resistant titanium fins, which withstand re-entry and can be reused with minimal maintenance. Beyond Falcon rockets, Elon Musk has unveiled something extraordinary, a craft called the X-1, drawing attention from the U.S. government. Developed in secret by SpaceX, the X-1 reaches hypersonic speeds of 4,600 miles per hour, is highly fuel efficient, and uses cutting-edge tech that blurs the line between aircraft and spacecraft. What sets the X-1 apart is its camouflage tech, allowing it to blend into the sky like a cloud, making it nearly invisible. The Pentagon once mistook it for a UFO, and even scrambled fighter jets to intercept. The craft's secrecy caused confusion in military circles, including among Hamas militants. The X-1 is powered by a compact space shuttle engine, first tested on SpaceX's Hawk hypersonic missile, and cuts fuel use by 30%. It's also equipped with microwave weaponry, capable of melting enemy electronics or aircraft, and even used for crowd control. When turned down, it causes intense pain, forcing enemies to flee and abandon gear. While the U.S. military sees its potential, Musk and the Pentagon disagree on its role. Musk views it as a strategic asset, while the military remains cautious. Despite this tension, the X-1 continues to impress. It avoids radar detection and flies at a staggering altitude of 105,000 feet, even higher than the State Route 71 Blackbird. With stealth, speed, and altitude, the X-1 could reshape both space travel and aerial combat. But it's not untouchable. Supersonic missiles are needed to challenge it. Still, jets like the F-35 and F-22 struggle to compete. The X-1 cruises at 4,600 miles per hour, while the F-35 maxes out at 1,200 miles per hour. By the time the F-35 responds, the X-1 could complete its mission and return without refueling. The F-22 and F-35 carry AIM-120 hypersonic missiles, which hit Mach 4, but only maintain top speed briefly. The X-1's microwave system, on the other hand, acts like a wide-beam laser, disrupting targets across a broad area, signaling a shift in how future battles might be fought. The X-1, Starlink, and the future of air dominance. At full power, the X-1's microwave system can melt enemy aircraft, but it's mainly used to disable electronics, turning advanced jets into flying junk. The tech fits into the Air Force's high-low mix, capable of disrupting both machines and humans. Its stealth camouflage allows it to blend into the sky, making it almost invisible to radar and the naked eye. Still, technology alone isn't enough. Skilled pilots remain critical. Human decision-making and tactics can outmatch any unmanned system. This mix of cutting-edge tech and human skill is raising the bar in modern aerial combat. Historically, only the State Route 71 Blackbird could fly at such altitudes. It wasn't designed to attack, but avoided threats by flying extremely high and fast, with radar evading shape and color. But now, the X-1 can fly even higher, and is almost unreachable by most air defense systems. To stop it, a fighter would need to get close enough to launch a supersonic missile, a tough task even for top-tier jets like the F-35 Lightning II or F-22 Raptor. Beyond aircraft, SpaceX has pushed into other areas too. Its Starlink project aims to provide affordable global internet. As of December 2022, it had over 1 million users. While astronomers worry about light pollution, Musk's efforts also support humanitarian causes. In 2018, SpaceX built a mini-submarine to help rescue Thai children trapped in a cave. During the COVID-19 pandemic, the company supported antibody testing, showing its broader commitment beyond space. Meanwhile, the U.S. is developing the F/AXX, a sixth-gen fighter to replace aging fleets. In 2009, Boeing revealed its stealthy twin-engine, tailless concept with a two-seat cockpit and blended wing-body design. It could be flown manned or unmanned, weigh around 40,000 pounds. Northrop Grumman's X-47B was also proposed under this program. In 2013, Boeing updated its design, still tailless, but now with canards for better control and diverterless inlets like those on the F-35. The manned version had limited rear visibility, relying on advanced sensors instead. In 2011, the DoD planned to retire older F/A-18 Hornets and bring in 220 F-35s, but the Navy also considered developing a new aircraft or combining both options. By 2014, the Navy launched a full analysis of alternatives AOA for the F/AXX. Rear Admiral Scott Conn later announced the AOA would be completed by spring 2019, with concept development continuing through 2024. Much of the project is classified under Link Plumeria, one of the Pentagon's biggest R&D efforts, focused on next-gen weapons, avionics, and mission systems.